Today we're going to start using quadratic equations to solve word problems. Now when we're solving these word problems, we can choose to either solve by factoring or to solve by completing the square. Use whatever you think fits the equation the best. If you have an even b value, it might be easier to complete the square, where if it's an odd b value, it's definitely easier to go through the factoring process. So taking a look at number 1, the length of a rectangle is 12 feet more than twice the width. The area of that said rectangle, so area is a huge hint here, is 320 square feet. Find the dimensions of the rectangle. So we want to figure out, well, what the length and width of this rectangle is. We know that the length is 12 feet more than twice the width, so we can assume that the width is x, and the length is 2x minus 12. Now again, I circled area before. We're talking area, not perimeter. So we don't start adding up all the sides. We multiply the sides. We multiply the length and the width, giving us x times 2x minus 12 is equal to the area of 320. I'm going to start putting that in standard form. So 2x squared minus 12x equals 320. I'm going to think about it here. Do I want to factor or do I want to complete the square? I have negative 12 in the middle. Looks like it's going to be easy to complete the square, so I'm going to go through that process. Factor out the 2. I'm left with x squared minus 6x. And then half of negative 6 is positive 9. So half of negative 6 is positive 3 squared, which is positive 9. Subtract the 9 and add it, equals 320. The first 3 terms give us our perfect square, so 2 times x minus 3 all squared. Bring the 9 out by multiplying it by 2, so we get minus 18 equals 320. Then we're going to add 18 to both sides. Which gives us 2 times x minus 3 all squared equals 338. Then we're going to divide by 2. So x minus 3 all squared equals 169. Take the square root, and we get x minus 3 equals 13, or x minus 3 equals negative 13. We add 3 to both sides. We get x equals 16, and adding 3 to this side gives us x equals negative 10. Now, in this case, when we're talking length and width and area, we cannot have a negative dimension, so that is not going to be the case. So we're going to choose x equals 16. So we now take the 16 and plug it in. 16 is the x. 2 times 16 minus 12 gives us 32 minus 12, which is 20. And we can check our work. 16 times 20 does equal 320 feet squared. So we are correct. So we list our dimensions as 16 by 20 feet. Number 2 is extremely similar to number 1. Go ahead and try that one on your own. Have your teacher check your answer before moving on to number 3. Okay. Number 3, we have the area of a circle is equal to 3 times the circumference. What is the radius of the circle? All right, so in order to do this problem, you need to know your formulas for area and circumference of a circle. So if you guys remember, area equals pi r squared. Circumference equals 2 pi r. So now reading this again, the area of the circle. So we're going to take our area formula, removing the A. The area of the circle is equal to 3 times the circumference. Now we want to start setting this equal to 0. So we have pi r squared equals 6 pi r. 3 times 2 is 6. Subtract the 6 pi r. Pi r squared minus 6 pi r equals 0. So now we can factor this. We have a binomial that has common factors. In each of those terms, we have a pi and we have a radius. So we can factor that out. So pi r times r minus 6 equals 0. So now we set our two terms equal to 0. Pi r can equal 0, or r minus 6 equals 0. If pi r equals 0, then r equals 0. Because to get it equal to 0, you have to have pi times 0. On the opposite side, you would add 6. So the radius has to be 6. Now, if we're talking about dimensions again, and we're saying that this is a circle that actually exists, obviously 0 wouldn't be the correct answer, and r equals 6. So now we can prove this, that it works. If 6 is plugged into the area would be pi times 6 squared, which is 36 pi. The circumference would be 2 pi times 6, or 12 pi. And if you multiply 12 by 3, where it says 3 times, you get 36 pi. So we are correct. Okay, number 4 is different than the problem you have in your notes. If you choose to copy it down, that's fine, but you can do the work in the space for number 4. Algebraically find 2 consecutive even integers that have a product of 624. So we have to remember our idea of consecutive integers from earlier in the year. 2 consecutive even integers. If we don't know them, we're going to call the first one x, and it's even, so the second one is going to be x plus 2. From there, they have a product, which means multiply, of 624. So x times x plus 2 equals 624. We distribute the x, we get x squared plus 2x equals 624. I'm going to solve this by factoring, so I'm going to put it in standard form first. X squared plus 2x minus 624 equals 0. Now, I don't know the factors of 624 off the top of my head, so I'm going to use my graphing calculator. Go into y equals, type in negative 624 divided by x, pull up the table, and look for factors that have a difference of 2. So if they have a difference of 2, I want to look for two numbers that are closer together, obviously. And I find that 24 and negative 26 are factors. So if 24 and negative 26 are factors, I could switch it to negative 24 and positive 26 so that I get positive 2 as my sum. So now I have x squared plus 26x minus 24x minus 624 equals 0. I group and I group. Take out x, I'm left with x plus 26. Take out negative 24, I'm left with x plus 26, because we just found above over there that negative 24 times 26 gives us the negative 624 equals 0. Factor out x plus 26, and I'm left with x minus 24. Set those two both equal to 0. So x could be equal to negative 26, or x could be equal to positive 24. So Find two consecutive even integers. There's actually two sets of even integers. So my answers would be -26 and -24, or +24 and +26. In each of those cases, I get a product of 624. Okay, now the last one I'm going to do with you is a little bit challenging. Take your time, go through it carefully with me. If you need to pause the video, make sure you do. So a small park is enclosed by 4 streets, 2 of which are parallel. The park is the shape of a trapezoid. So it would be helpful if you remember what a trapezoid looks like. It kind of looks like this. This is what we call a regular trapezoid. I'm going to pretend we're doing a regular one right now, where this side is parallel to this side. The distance between the parallel streets is equal to one of the parallel sections of road and 20 feet longer than the other parallel section of road. The area of the park is 9,000 square feet. How far apart are the parallel streets? Now, it would have helped if I drew my picture after I read the rest of the problem, so I'm going to go back and redraw it. Because it says the distance between the parallel streets is equal to one of the parallel sections of road and 20 feet longer than the other parallel section. So the distance is going to be equal to the longer side of road. These sides are parallel. This side is x. And as it says, the distance between the parallel sections is equal to one of the parallel sections of the road and 20 feet longer than the other parallel section. So this is x plus 20, as is this. Okay, so I know it doesn't look exactly to scale, but you should get the idea there. So now the area is 9,000 square feet. How far apart are the parallel streets? So we have to also remember how to calculate area of a trapezoid. So area of a trapezoid is found by doing area equals height times base 1 plus base 2 divided by 2. Or area equals 1/2 the height times base 1 plus base 2. So now we're going to plug everything in and start to solve. So I'm going to use the one with the half. I just wanted to show you the other one, because I think that's the one you probably are a little bit more familiar with. So we're going to have 1/2 of the height, which is x plus 20, is equal to base 1 and base 2 being added together. So x plus 20. And that equals the area of 9,000 square feet. Now we start the process of simplifying this. So 1/2 of x plus 20 times 2x plus 20 equals 9,000 square feet. Then I can either distribute the 1/2 or double distribute first. I'm going to go with double distributing first. So 1/2 x times 2x is 2x squared. X times 20 is plus 20x. 20 times 2x is plus 40x. And 20 times 20 is 400. Equals the 9,000. Then bring the half down, simplify the parentheses. 2x squared plus 60x plus 400 equals 9,000. Now I can cut that all in half. Half of 2x squared is x squared. Half of 60x is 30x. Half of 400 is 200 equals 9,000. Now I can go about it 2 ways. I could complete the square, or I could solve by factoring. I'm going to go ahead and solve by factoring. So I'm going to subtract the 9,000, x squared plus 30x, and then 200 minus 9,000 is negative 88,000, or negative 8,800 rather, equals 0. Now I need to factor. So I have negative 8,800, and I do not know the factors of negative 8,800 that are going to have a difference of 30. So I'm going to go into my calculator, do negative 8,800 divided by x, pull up my table, and look for factors that are 30 apart. And because the number's so big, we're going to have to scroll down quite a bit. So we get numbers that are closer together. And I found 80 and negative 110, which are 30 apart. So I'm just going to flip it and do negative 80 and positive 110. So x squared plus 110x minus 80x minus 8,800 equals 0. Group and group. X times x plus 110 minus 80 times x plus 110 equals 0. Factor out the x plus 110, and we're left with x minus 80 equals 0. Set each set equal to 0, or each factor equal to 0. And we have that either x could be negative 110 or x could be 80. So again, we're talking about dimensions here. We're not talking about just negative numbers or consecutive integers. So we can only choose the one that would actually work in this case, which would be x equals 80. And now we need to plug it back in to show our dimensions. So if x equals 80, that means the smaller base is 80 feet. The larger base is 80 plus 20 or 100 feet. And the height is also 80 plus 20 or 100 feet. And we could double check to prove that this works. If we plug it back into the original equation here, half of the height, which is 100, is 50. And 100 plus the 80 is 180. So this would be 50 times 180. And if you multiply 50 times 180, you do get, I didn't mean to erase that, but if you multiply 50 times 80, 180, you do get 9,000, which is the area we're looking for. So now you're going to go ahead and answer the exit questions, and then you can start your homework. Good luck, and if you need to look back at the video, you are welcome to.